In this video, we're going to look at comparing values from different data sets. So, when we're interested in looking at two different groups of data, it can be difficult to compare them because maybe it really doesn't make sense. For instance, if one math teacher teaches statistics one term and a different math teacher teaches statistics the next term, and students are comparing how they did on the first exam, it might be difficult to do that comparison because maybe one teacher gives harder exams than the other. So maybe overall, getting a C on one teacher's exam is like getting an A on the other teacher. So it kind of is difficult to make those types of comparisons. The way we make those comparisons is to compare the means and standard deviations. So what was kind of brought out of this is this idea called a z-score. So a z-score represents the data value and how far it is from the mean in terms of the standard deviation. So when I look at the population, I'm comparing it to mu and sigma. For a sample, I'm looking at it compared to X bar and S. And if I said that Z equals 1.5, that means that whoever Z, whatever data value Z is based on, that this data value is 1.5 standard deviations above the mean. If it had been a negative, that would be below the mean. So they'd be below average. And it allows us then that if we have two different z-scores, we could then make a comparison. So if this happens to be test one for the first class under one teacher, and let's say the z-score for the other one, this test one, okay, so here I'll call it Z1, Z2. Now, comparing them, I see that one person scored 1.5 standard deviations above the mean, where the other person scored 2 standard deviations above the mean. So, relative on this test, this person did better because they scored 2 standard deviations above the mean. They're much higher above the mean than the other test score relative to their mean. That's why this is kind of useful for comparing data sets. So, let's look at an example here. So we have two swimmers, Angie and Beth, and they're from two different teams. And of course, we know that some teams might underperform compared to other teams. So if you're from a high performing team, you might be swimming faster, but compared to the rest of your team, maybe you're a little bit slow. So we want to know who has the fastest time on the 50-meter freestyle when compared to the team. So let's look at the information for each person. Angie, I'll go ahead and find her z-score based on her team information. So let's see. I'm going to go ahead and call this Z sub A. So I'm going to take 26.2 minus 27.2 and divide by 0.8. Now, if you put this all into your calculator all at once, okay, it's really important that you put parentheses around the numerator when you do that, or hit enter, like calculate the numerator first and then divide by 0.8, because otherwise you'll come out with a bad calculation. So when you plug this into the calculator, you should get negative 1.25. So they are a little over 1 standard deviation below the mean. Okay, so they're actually performing below the mean, which makes sense. Her time is less than the mean time. Now, in terms of freestyle swimming, low time is good. So when she's performing below the mean, that's actually a good thing. That means she's going faster than the rest of her team. So in this case, when we're saying below, that's not a negative context. It just means that compared to everybody else, she is lower than the mean. Okay, let's go ahead and look at Beth now and her standard deviation. She's also below the mean, which is a good thing in swimming. So 27.3, that's her time. And I'm going to subtract the team's time. Oops. Oh, man. Let me fix that. Okay. There's something on my screen that's causing my line to come out badly. There we go. All right. And we're going to divide that by 1.4. All right, so putting that into the calculator, and again, be careful, make sure you use parentheses if you're going to do it all at once. Otherwise, do it in steps. Hers comes out to -2. Okay, so Beth happens to be lower in her average swim time compared to her mean by 2 standard deviations, where Angie is a little over 1 standard deviation. So, in terms of who the better swimmer is, who the faster time is, it's Beth because she is much lower than the average compared to Angie in her swim team's time. And you can kind of notice that Angie, her swim team is pretty good. They're pretty strong. Their overall mean time is less than Beth's. But compared to her team, then Beth is performing much better than the rest of her teammates.